Alrighty, so for our first build, we're just going to make a very simple circuit. We have some power wires. Those are going to be hot and ground. We have a simple switch, an LED and a resistor, and then some general wiring to make this whole thing work. So the premise behind this is when you drive a current through an LED, it lights up. We chose green because I like green. So we're going to put in hot, and we're going to put in ground. The cool thing about these breadboards is, so this is an electrical, well, it's called a breadboard. So basically what it's for is we can prototype circuits with it without having to solder all the pieces. There's two power rails on either side, and as you can see, there's like a hot and a cold right here. So these lines go all the way down for both of them. So you have an entire row of hot that are all electrically the same potential, an entire row of ground that are electrically the same potential, and then you have this other side that is separate from that, but it does the same thing. Whereas all these other rows, you can see they're marked with letters and numbers. Each one of these, each row is electrically the same, and it's split across here. So that gives you somewhere near 65 rows of different electrical potentials, and then you have a second one right here. So there's lots of different connections you can make this with this. These breadboards are awesome. You can actually get multiple and stack them together. So this is actually two different breadboards, and they just pop on and off. So super useful things when you're prototyping, because you don't have to commit a bunch of soldering. You can just put your stuff together and figure it out. So let's move on to the LED. Like I said, LEDs are very simple components. You'll find them in almost any modern technology. They're good for indicators. They bring an abundance of light. They're low power consumption. And very, very basically, to just get an LED to work, you're going to want to put a resistor on it, and you're going to want to have the actual LED. What the resistor does is an LED works based off a certain voltage, so it only requires a specific voltage in order to activate. The problem is that there's a lot of remaining voltage in your circuit. So if you leave it by itself, all of the voltage from your circuit drops across this one thing, and that can cause the bulbs to burn out. In fact, we'll show that here real quick. That'll be kind of a fun demonstration. It's a loss of an LED, but LEDs are rather abundant and cheap. So we'll take this spare, and I'm gonna crank up my power supply to 12 volts, which is way too much for an LED. But if we grab hot and ground and we touch it, you'll see a big, oh, wait, hold on. It's harder to do. Yep, we got one little flash out of it, and it's gone now. This guy will not turn back on. So he blew out. So that's what the resistor is here for. The resistor will prevent you from burning out your LEDs. Alrighty. So we're gonna put hot and ground in. That's gonna get our whole railing. And then to make this other side electrically the same, what we're gonna do is we're gonna bridge both sides. Now this is not required for most builds. It can be useful when you wanna be able to put power across both sides. But there's a lot of other ways you can do it. You could have a 5 volt on this side, a 20 volt on the other side. And because the rail is the same potential, if you wanted to put like one connection to all the other connections, you could also use the railing in order to get a lot of different stuff on. So very useful rails. We're gonna put them together because it's just a simple little build. On your LED, you have a long leg and a short leg, and you also have a flat side and a rounded side on the actual LED. The flat side is negative, so you want to make sure that that is going to ground, which makes the long side positive. And so we're going to get hot from this side of the rail, and I'm going to bring back to ground. So the way our electricity is flowing right now is we have hot coming in, it hops over to this side. We're going to put this guy in like this. I'm going to put him in the middle. And so now he is isolated, but he's ready to get connected too. A very simple circuit. We can put, now he has a hot side, but there's nowhere for the power to go. so it won't do anything. But as soon as we connect a ground wire, we'll see we get a light. Ooh, very bright light because I didn't put the resistor I was talking about down. Now you notice that didn't pop that time. It's because the voltage is much lower. So it can handle some voltage, but you want to put these resistors on there to protect it mostly. Oop, and there we go. Now you can see we have a working LED. But that's not so much fun inside of itself. It's just an LED, it's a light, it never turns on, it never turns off. There's only so much functionality you can get from something like this. It's useful as a power indicator, so you put this on in between your switch and your power supply. And then if it doesn't turn on when you turn your switch on, you know that there's a problem with power, right? So it can be useful like this, but it's better if we can give it some functionality. So what we're gonna do is we're gonna attach a switch, and this little switch is gonna let us control when the light is on and off. And the switch is actually pretty cool. It has a normally open and a normally closed state. So our first wire is gonna just be our common. This one's gonna connect to both of these guys. But these guys are special. The first one is normally open, which means if I just put it to that switch and I'm not pressing down, it's just like it naturally is, the switch is going to be considered open and there's not going to be any flow of electricity. If I put it on the second one and I leave it just how it is normal, it's going to be considered closed and electricity will be able to flow normally. Then when I depress the switch, it'll either turn on or off depending on which one we're using. We'll play with both of them because it's not really that hard to change. So what we're gonna do is we're gonna put our switch in, and now we're gonna take power away from him because he's not gonna have it directly anymore. And we're gonna start with our normally open. So when I plug this in, we're not gonna see anything. It is just going to be dark. We'll put our ground wire back in. Okay, and now we have a complete circuit again, but our switch is open, so we're not gonna see light. If I click down on it, we get light. And now you almost have a Morse code. Something like that. It's not huge functionality. You consider this like a flashlight or something, but it's a little bit more of an advanced circuit than just wiring everything in hard. Like I said, this has a normally open and a normally closed, so now you can see I moved it to the normally closed position of the switch, and that turned the LED on. But now if I press the button, the LED turns off. So cool little switch here. It has different functionality. The LED and the resistor are nicely paired together. And you got to see one pop. I don't feel like it was a really good pop though. I wonder if I can get a better one. Maybe just one more because it is kind of fun. Let's try 9 volts. Maybe that's enough to grab or set one off. Okay, let's see. Oh, it popped it, but it didn't last very long either. So you go, 2 popped LEDs and a simple circuit.